Okay, this is the first video on the topic of uniform circular motion. By uniform, we mean that an object is moving with constant speed in a circle. So it's a circular motion, and but the particle or object itself is moving with constant velocity. So let's look at how circular motion is caused. So for example, suppose we got an object which is traveling in this direction, and Newton's first law of motion says that any object or particle would maintain its state of motion. So this particle would keep on going in this direction. If we want this particle to move in a circular motion here, we need to pull this particle in this direction first. So we need to pull it in. Now suppose we apply a force here to pull this particle in. The particle will keep on going and it will go like this. It will still not move in a circular motion. So what we need to do is we need to pull the particle again here in this direction. And if we pull it in this direction, it will keep on going like this. So we see that at every step we need to pull the particle object in to make it move into circular path. So the intuition would tell us that if an object is in circular motion, then something is continuously pulling that object or particle in a circle. So we can effectively say that if this is it hasn't come out as a good circle. Let me draw it again. Hopefully this time it will come out all right. I'll give one more try, and not then I will just accept whatever I get here. So this is my uniform circular motion. It's an oblong circle, but we'll take that as a circle. So the particle is moving in this direction, then every time something is pulling that particle towards the center. If this force is not there, particle or object would keep on traveling in a straight line. So for example, if this force is not here, then the particle will keep on going in this direction because it will go with the same velocity. And if we want it to go in the circle here, we need to pull it in here. So I'll write that as a sentence. Let me write in a different way. If an object is moving in a circle, there must be some force acting on the object to it hasn't come out all right. So there must be some force acting towards the center on the object. Now this is a really important statement if you look at it. So no object can be in circular motion. No object can be in circular motion without something pulling that towards the center. So there has to be a force pulling towards the center, and this force is known as centripetal force. Centripetal means towards the center. Yeah, so just to repeat that, uniform circular motion would not be possible without a centripetal force. Okay, other consideration here is that our object is on this circular path and its speed is constant. Say suppose for example speed is equals to 5 meters per second. So the question that is asked is there some acceleration? Is the particle or object experiencing any acceleration? So the speed is constant, but we just need to remember that the speed is constant, but velocity at any point is along the tangent of the circle. So it means that the velocity is changing direction every second. So this is velocity vector, that is velocity vector along the tangent to the circular path. So velocity is a vector, it has magnitude as well as a direction. Magnitude is the speed, but the direction here is changing every moment. So there is some acceleration. Now we can come to this conclusion from looking at the existence of this force as well. We remember that wherever there is a force, I think it's worth repeating this equation here. Wherever there is a force, there has to be an acceleration. Without the force, there cannot be an acceleration. So their centripetal force is there. It means there will be some acceleration as well. And we also know that force and acceleration always have same direction. Force and just write in short, acceleration always have same direction. So therefore this acceleration is known as centripetal acceleration. So just to repeat that, if an object is in circular path, it is undergoing acceleration, and the name of that acceleration is centripetal acceleration. The symbol we use is AC, C for centripetal, and likewise for force as well, we use the symbol FC, which is basically centripetal force. All right, and just one more thing, this centripetal acceleration is found, and it is equals to centripetal acceleration is equals to v square over r, where v is the speed and r is the radius of the circular path. Because this is a very important relationship, and using this equation and this equation, we can find centripetal acceleration as well. We know that force and mass are related by, force and acceleration are related by this equation. So here, if we are talking about centripetal force, then this is centripetal acceleration, which tells us that centripetal acceleration is equals to m times AC is this v square over r, or I write like mv square over r. So these are two really important equations, and most of the problems that we come across will be on this equation here, and we will now take a look at some of these problems here. So this is my first question here. It says an object tied to a 2-meter rope is moving in a uniform circular motion. The mass of the object is 2 kilograms. The speed of the object in its circular path is 12 meters per second, and find the centripetal acceleration and the centripetal force responsible for this motion. So as per the best practice, we normally list the quantities that are given there. So we have m is equals to 2 kilograms, r is equals to 2 meters, and v is equals to 12 meters per second. We need to find AC and we need to find FC. All right, so AC is equals to v square over r. Substituting the value here, v square is 12 square over r is 2, which is 144 over 2, which gives you 72 meter per second square. And if we want to be really pedantic, we could say that is directed towards the center. We can mention the direction as well, directed towards the center. Likewise, FC is F equals to m times A. F equal to m times A. M is 2. AC is already we found 72 here. 2 times 72 is equals to 144 Newton. A straightforward question. We just need to plug in the values, just need to remember the formulas there. Let's look at one variation on this question. we will have many variations, and you can have, you will have all the quantities given but one, so, and you will be required to find the missing quantity. So this here is, again, we got this mass, you got, let me list the quantities. M is equals to 1.9 kilogram given there, tied to a 1.2 meter rope. So basically that's the radius, 1.2 meters. And as discussed earlier, if there is some object is in circular motion, so there must be some force providing the centripetal force, someone providing the centripetal force. And in this particular case, it is the tension in the string or tension in the rope which is providing this centripetal force. So Fc is equals to tension in the rope, which is equals to 100 Newton. And we need to find the V. All right, so simple equation, Fc is equals to mv square or r. Substituting the values, Fc equals to 100, m is equals to 1.9, v square divided by 1.2. So we want to get v square all by itself, which means we need to get rid of this 1.2 and 1.9. Simply get rid of this by putting 1.2 in the numerator here and here, and get rid of 1.9 by putting 1.9 in denominator. So 1.9 here. That gives us 1.2 times 100 over 1.9 equals to v square, which gives you v square is equals to 63.16, and that gives you v is equals to 63.16, which is equals to 7.95 meter per second. And next one is we found the velocity. Next one is find the acceleration of the object. Now we are given f and we are given m, so we are given that, I can write that again. We are given the f is equals to 100 Newton and m is equals to 1.9 kilogram. So we just use the equation f equals to ma. So sorry, this is c here. That gives you ac equals to fc over m, which is equals to 100 over m is 1.9. That gives you 52.63 meter per second square. Yeah. Let's look at one more problem. This is slightly different. So this time you got an object 1.5 meter, 1.5 kilogram, radius is this. Some of the information in these questions are not needed, and in fact we are not using those, we are not finding acceleration and centripetal force here. Let's take a look. The radius is this and the speed of the object is 5.1 meters. So let's write this thing. R is equals to, I'll start with m because m is also given. So let's write m is equals to 1.5 kilogram. R is equals to 4.1 meter and speed is equals to 5.1 meter per second. What we need to find? We need to find the acceleration of the object. Okay, so we are finding the acceleration object, which is v square over r. So we can find that v is 5.1 square divided by r. That will just take me a second. Divided by 4.1 is, it gives me 6.34 meter per second square. Okay, next thing is find the time it would take to complete one rotation. So we need to think like this, that suppose we got this is our circular path. So we need to find how long it would take to complete this circular path here. So we are looking at time to go this circumference, and this length of the circular path is equals to 2 pi r, which is circumference of the circle. So this is 2 pi times r is we already got that 4.1. So that gives you, we can keep it like this. So this is one circle. This is my one circle, and we need to travel that much distance. and the object has got a velocity of this much. So time taken for one circle is this distance 2 pi into r divided by the speed of the object, and the speed is 5.1, and that gives us a time of 5.05 second. In fact, if you are looking for a ready-made formula, this we can say that this t is the time period basically, which means time for one rotation, is equals to 2 pi r over v. So sometimes this formula can be used. And next thing is that we need to find the total RPM, revolutions per minute. So we find that for one circle it takes 5.05 seconds. So one circle it takes 5.05 seconds. So we need to find how many circles it would complete in 1 minute. So basically all we are trying to find how many of these 5.05 goes in 60 seconds. So RPM, revolutions per minute, revolutions in 60 seconds is 60 divided by 5.05, and that gives you 11.88. That is our RPM.